Hi, myself Naveen Kumar Sain. In the course Wireless and Mobile Communication, code KEC 076. In Unit 5, we will discuss the next complex topic from the Unit 5. So that topic, that is the Introduction to Mobile Ad hoc Networks. So first thing which is very important to know about what is the meaning of the ad hoc and how it works, and then what is the next point, that is the MANET, mobile ad hoc network. So the term ad hoc means the temporary or when it is required or needed. So this is the meaning of the ad hoc networks. It means, so whenever the network we designed, in that network, if we want to use in cells, or we want to use the nodes, and we have different nodes into the cell, right? So as per our requirements, so any node can transmit the data to the another node, and the another node can transmit data to the third node, and so on. So it is temporary. It means this is not fixed in the ad hoc networks. The architecture is not fixed. Is not the fixed architecture in that. This is a configurable or reconfigurable architecture in that. So in the phase ad hoc network itself tells meaning of the ad hoc network, as we said, temporary or when it is required. So it means a network that temporary or set up immediately when needed for random temporary access of the network. So it means that any node which is mentioned here in the diagram, that any node can be moved anywhere. So these are different nodes which we are deploying. So these nodes can be your mobile phones, or these nodes can be your sensors, okay, can be as a router. So these different type of nodes can be specified here. Okay, so in that, ad hoc network is a group of locally available devices. So as I said, the devices like the mobile phones and sensors which we deploy into the wireless sensor networks. So these are example of that, and any device can communicate with the another device at any time, or directly, which is very near to the particular node. And second, if any device is very far away from that node, so intermediate nodes can be act as the routers for those source and the destination. Okay, so there's a basic definition about the ad hoc networks. So next is the MANET. MANET is the mobile ad hoc network. So in that mobile ad hoc network, these devices are movable. So these can move from one point to the another point. So there are some of the features for that. So in that, no hardware or fixed infrastructure is required. Okay, so it means these are mobile in nature. So these mobile devices, these involve to talk, transfer data directly to the each other autonomously, and they are not fixed to the particular location. They can be moved anywhere. That is why there is a mobile nodes. And another feature of this MANET system, that is the self-repairing. If any node is found any link fault, or there is a fault into the nature of any node, so it can repair itself. So these are one of the features. Next is auto configured. So as I said, these are not the fixed architecture. This is the movable architecture. So architecture can be changed, or the infrastructure can be changed automatically. So this can configured automatically itself. It means if mobiles are they are movable in nature, so the number of nodes can be increased or decreased in a given area. It is also known as the wireless ad hoc network. That is a WANET. Okay, WANET, and these are flying networks or spontaneous networks, we call it as. Each device itself, it can be act as the router. It can be used for transfer device and transfer the files from one node to the another node or another devices. This is a very simple architecture. So when we talk about the working of the MANET, so in that it works as an individual exclusively in a group as a part of the huge network. So as I said, if we have some of the kilometers of 30 kilometers, just like the one area of there, in the 30 kilometer, we can divide this 5 kilometer each area, and the number of subscribers into that 5 kilometer each. So that is the group of the devices which can communicate from one to another. So number of devices can be changed as it is moving from one zone of one area to the another area. So in that second feature of that is MANET, that is no access point or hardware is required to communicate one's device to the another device. This is a direct and autonomous communication between the mobile devices. So these devices searches each other. Okay, they search themselves and start communicating. So as I said, and one source is there, one destination is there. So by applying the different algorithms, the one source will search this particular device or destination device automatically. They will search it, and then after searching, they will transmit the data to that particular devices. So if the node is very far away, then in that case, the nodes between the source and device sources and the destination will act as in the routers. Okay, so as I said, if it's a source, this is the destination node, and if one node wants to transmit the data to the destination node, so in between these two nodes, if there are some nodes are there through which this data is transmitted, right? So these will be act as the routers. So in between intermediate nodes are act as the routers for the source and the destination devices. So these devices can join or leave the network because these are movable in nature. So at any time they can leave it, and they can remove this removal or addition of the nodes can happen into the given network. So these devices have their own backups of the energy, which has like the batteries or the power, anything which can give the power to that device. Okay, so every node has this type of facility itself in the MANET system. So some of the applications of the MANET system is there. First one is the gaming services. So these gaming services are used for collaborating the gaming in the local area, just like the LAN system which we have used in our system. It's like in Counter-Strike, if you want to play that game, and we are connecting the different devices at the same time. So if the 5 devices are connected with the LAN system, so fiber optics were included in that. But in place of optical fibers, if we are using any wireless system in that, so that same game can be played simultaneously in all the systems. The gaming services are there, military services. So these military services for immediate sending information to all remote area, to the all remote troops, battalions for the meetings, etc. If we want to broadcast the information to all the nodes, right? So in that way, this is one of the very good facility. I mean, one of the good thing which is having in the MANET system. Any node can broadcast information to all the devices which is very near to the network. And in that important point is also there when there is areas like rural areas, suburban areas, or the urban areas. So based on this area or these geographical conditions, we can deploy the different sensors as well. Commercial use. So local conferences can be happened through this events, seminars. So these MANET system or architecture can be used to for facilitate these local conferences, events, seminars, etc. Industrial sector is another sector in which this MANET system can be used. Like if in the industrial sector, if we want to deploy the different sensors, so these sensors can check the leakage of the gases or the any leakage of oil, and so many oil, if there's some burning or temperature increase. So many factors are there which can be checked through in the MANET system as well by deploying the different nodes. So next is the emergency services like the earthquakes, disaster relief, and firefightings, and so on. There are so many applications again in the case of the mobile ad hoc networks, which we can go through it. Then we have the education sector. So this is a very well-known system in which in classroom or the labs of schools, colleges, etc., where lecture theaters are there. So where we can deploy the different nodes as per our requirement, and we can facilitate this network as well, right? So one of the best example of the application of the MANET system is the Bluetooth. In the Bluetooth communication, we use the different standards for deploying the nodes, and different algorithms can be used for this system. So there are some of the characteristics of the mobile ad hoc networks in which the no centralized control is there. As I said, this is reconfigurable itself, and there is no access point for all the nodes, right? So this is one of the very unique feature in that every node can be act as the access point, every node can be act as a router, every node can be act as the source or destination as well. So there is no central controlling of the deployment or deploy of nodes are necessary. So the working is completely dependent on the behavior and support of the participating devices. So then random change of devices. So device keep coming and leaving the network. So and with a very high velocity, with a high speed. Okay, so in this case, the topology and the number of users, everything will be changed. Number of users, this will change into the system. So frequently change in the network topology is also there. Maybe some of the nodes is acting as star topology, ring topology, and so many topologies are there. So as the movement of the mobile phones or the different sensors, these are moving from one location to another location. So definitely the network topology will change. So another, the limited bandwidth power is there. Less or limited human interventions are there, because if you're deploying the sensors into the hilly station, so hilly area, so there is very less movement of the human being, so this intervention is very less in that case. Less security, right? So these networks have a bigger disadvantage or threat is the security point of view into the wireless sensor networks. So these devices involved in the networks, so smaller networks nowadays can be used. Can be used for can become the victim of theft cases are involved in today's scenario in the managed system. So we have to use the different devices which is of very high capability to handle this type of situations, and the threats can be removed. So these are the again characteristics which can be used, or some of the drawbacks also, which is we have taken care of. It can be attacked easily. Each device act as a router, as I said ahead of the networks. Device can be used for multiple roles, as I said earlier about the source, destination, routers, modems, and so on. Limited bandwidth, these are the constraint in the network, which has very little capability of the data transmission. Low resources such as memory power, battery power. Performance is high with the low expenses and scalability, and which is one of the advantage in the case of the MANET system. So there are the differences between the cellular networks and the ad hoc networks. So in the cellular system, as we are very much aware about the cellular system, where we have the one base station, and this base station is used for generating one of the cell, and in that cell we say there is a different number of users are there accommodated into that. So in this cellular system, the network routing of the cellular network are centralized, and all traffic goes through the base station. As I said, the base station is there, and this base station will control all the subscribers into the given cell. The circuit switched are used in the case of cellular networks, and it has the single hop type network is there. Base station is there, one mobile station is there. If one mobile station wants to work onto the another mobile station, so it has to hop with the base station as well. Then store topology, which are used into that cellular system. Then it takes higher cost, takes more time for deployment. It is used to design and develop for the voice traffic as well. So in terms of the ad hoc networks, what we have, so in that these are reconfigurable systems there in the ad hoc network. So network routing of ad hoc networks are distributed in nature. There is no centralized system, just like the access point is not there in the case of the ad hoc networks. It is completely dependent on the packet switch networks. It has multiple hops. As I said, if we have node number 1, node number 2, node number 3, and if this node number 1 wants to communicate with the node number 3, so it have to hop 1 to 2 and then 2 to 3. So this is a route discovery is there in the case of the ad hoc network. So mesh topology are used in this in the case of ad hoc networks. It takes lower cost, which does not take more time for the deployment. So simply you can deploy the nodes into the given area, and this is automatically usable. So in the case of cellular system, we have to first deploy, establish the one base station, and then the mobile phones which is suited to the base station can be communicated with each other. It is used in the design to meet best effort data traffic requirements. This is really very, when we have the low capacity data, so for that one, the mesh or ad hoc network is one of the very efficient technique for transmitting the data from one node to the another node. So in the cellular network, low call drops during the mobility is there. It requires periodic maintenance, so it is costly in nature, obviously. So allocation bandwidth is guaranteed and the easy. And some of the example in the case of the cellular network is the IS-95, IS-136, GSM, Mobile WiMAX, CDMA, LTE technologies which are used into that in this system. Okay, so all the 2G, 3G, 4G and 5G system is again use the cellular networks. Frequency spectrum is reused through the geographical channel. So this is the advantage, or these are the characteristics of the cellular network. In the same constraint, we have the ad hoc network where the higher breaks in the path during the mobility. Here nodes are self-organizing and hence it is less costly. The allocation of bandwidth is based on sharing channel using the complex MAC algorithm, right? So here the WLAN 802.11e technology are used into the ad hoc networks, and dynamic frequency reuse through sense mechanism is there into the ad hoc network. So there are some of the examples and the differences between the cellular network and the ad hoc network is given. So MANET is representing here in the diagram form that if every node has some of the coverage area, right? So in that we can see the node A, node B, node C, and node D. So for the node A, we have the coverage area in the circular fashion. It means one of the omnidirectional antennas are used for this. So coverage for this is this one for A. Similar to that, for B, we have this coverage like this, and for C, we have this coverage, and for D, we have this coverage. Okay, so in this, these are overlapping coverages of A, B, C, and D, but at some instant of time, we can see when the mobile is in the nature, mobility in the nature. So in that case, we can see that A, B is moving, C is moving, D sometimes, if it is fixed, then path will be like that. So here, if we want to move from A to D, so it means from A to C, C to D. Now, if we want to again move A to D, in that case, we have to move from A to C, C to B, B to D. So this is the path through which we can transmit the data from A to D. So here, for this case, the router is the C, but in this case, the routers are C and B. This is the case in the mobile ad hoc network. Okay, so there is no pre-existing infrastructure is there. So this infrastructure can be changed when any of the node is moving from one point to the another time. So every time these nodes information will be updated into its own table. Okay, so this will depend upon the routing algorithm which we are applying. Okay, so nodes can be act as the routers to forward the packets for each other, and node mobility may cause the routes can be changed, just like A to C, C to D, and here after some time the route can be A to C, C to B, and B to D. So this is the way through which the routes can be changed. Next is the routing protocols. Now we come to the second section of this MANET system. So basically MANET system depends on this, obviously, routing protocols. So these routing protocols are of three types basically. First is the proactive routing protocol, reactive routing protocol, and third one is the hybrid routing protocol, which is a combination of the preactive and the reactive routing protocol, right? So this is nothing but the addition of proactive and the reactive, that is equal to the hybrid routing protocols. So in the proactive routing protocols, there is in proactive, what is the meaning of proactive? It means every nodes have the information through which it has to follow the path, it has to transmit the data, and to whom it has to transmit the data. So everything is already predefined in the case of the proactive routing protocol. Okay, second is the reactive routing protocol. In that reactive routing protocol, it is completely depend on the on-demand requirement. Okay, on demand, it means if one node wants to transmit data to the another node, so in that case, now it has to find the route first, discover the route first, and then it will transmit the data. So it has to find the routes in the reactive routing protocol, but route is already defined into the proactive routing protocol. So this is completely based on the table driven. It means driven, and this is based on the on demand. So this is the basic difference between these two. And as I said, hybrid is a combination of proactive and the reactive. So it means the advantages of the proactive and the reactive can be combined and it can be used into the hybrid routing protocols. So proactive routing protocols have DSDV. These are the examples: proactive routing protocol, DSDV, and the GSR. In reactive routing protocol, we have the examples DSR and the AODV. In the hybrid routing protocol, we have the example, that is zone routing protocol, ZRF, which are used for the hybrid routing protocol. So in that, what they have done in the zone routing protocol, in a complete area, they divide the complete area into the different zones into the hybrid routing protocol. So just like this is zone number 1, this is zone number 2, and so on, zone number 3. So suppose if we have a source and destination into this zone 1, so in this case the directly proactive routing protocol can be used, okay, when the source and destination both are in the zone 1. Now suppose the zone 2 has a source and the zone 3 has a destination. So in this case, source and destination both are in two different zones. So that is why zone 2 has a source, zone 3 has a destination. So in this case, we have to require the reactive routing protocol. Okay, reactive routing protocol can be used in the hybrid case. So proactive, as I said, this is completely table driven routing protocol, and each mobile node maintains a separate routing table. So this is a very, very important point. Routing table is already maintained by each mobile phone or each nodes into the when we are using the proactive routing protocol. This is a very basic thing which is have to take care of. Second point in that, update periodically. So every table which I am talking about, so table driven routing protocol, in that routing table will be there, and this routing table will be update continuously after some time. I mean, the periodically it will be updated. Okay, so because there are network topology which are changing regularly, and there is a limitation which doesn't work for the large networks, right? So if there is a large network, so table have to maintain, it's very tough to maintain a table for the complete network. All the information will be included into that, into the nodes table. So every node has to maintain, have to change all the time. Updation is required frequently. So this is very tough to maintain for a large network system. So one of the example for this proactive routing protocol, as I said, is a destination sequenced distance vector routing protocol, or in short we call DSDV. So this DSDV, destination sequenced distance vector. Okay, so again this is the table driven routing protocol, as I said, and it is completely based on the Bellman-Ford routing algorithm. So when you go for the data structure scheme, so in that data structure you can study this type of different algorithm which are used here. So this is the advancement. DSDV is the advancement of the distance vector routing, DVR, right? So DVR. So in this case, this distance vector routing which was used, the protocol, and it is used for the ad hoc networks, but this was not suited for the mobile ad hoc networks, because all the time there is a counting count to infinite, right? This problem can occur. So it means there is solution for this destination sequence distance vector routing protocol. So in this distance vector routing protocol, what happened? The sequence number is there, and this sequence number is added into every routing entry. Okay, so this routing entry can be happen into the routing table, which is maintained by each node. So a node will include the any new update into the table, and if entry consists of the new updated, routes to the destination with the higher sequence number. So as one node 1 to node 2, so node 2 to node 3, node 3 to node 4. So higher sequence number will be added into that. There's a 1, 2, 3, 4, 5, 6, 7, like that. So these sequence numbers can be added into the destination sequence number distance vector routing protocol. Next is the global state routing protocol, which is based on the Dijkstra routing protocol, and it is advancement of the link state routing protocol, in which the wired connections were there between the different nodes. But here in the global state routing protocol, what they have done, because if we talk about the wired connection, so in that wired connection, there is a conjunction will be occurred when we are broadcasting the information through the different links in the star topology, if I am talking about. So for that we have to, if one node is there, it guys is transmitting or broadcasting to other information to all the users. So in that case, for the large network, what will happen? The conjunction will occur. So to avoid this situation, we have the global state routing protocol, in which what happened, doesn't flood the link state routing packets globally into the network. What happened in the GSR? In each of the mobile node, in that it maintains one list, okay, one list and the 3 tables. So these are namely as the adjacent list, topology table, next hop table, and the distance table. So they are different tables are given in the when we are using the global state routing. So when the information is transmitted or broadcasting from one node to the other nodes, so these tables will be updated logically as well. Reactive routing protocol, this is completely based on the on-demand routing protocol. So in that on-routing protocol, what happens, whenever requirement is there between one node to the another node to transmit the data, so in that case, every node has to check or discover the routes. So these routes will be from one point to another point to next point, and so on. So here we can see if a node A wants to transmit the data, and this guy, and their different nodes are allocated, right? So these are the nodes which is given, and here we want to transmit the data from node A to the F. So first of all, so this is the source. So this is the source and this is the destination, right? So it means first thing what this guy will do, this guy will broadcast the request. So this is the request. This is the request which is broadcast by this A, and again this B is as a router. So this is again send the request to the nearby nodes. Again it will send the request to nearby nodes like this. So at the end, this guy will find that A and F, this can follow 2 paths. First is this one, A to B, B to C, C to F. Second path will be A to D, D to C, C to. Which one is the optimum path? So this guy has to select, right? So after discovery of this path, then A will transmit and F will be receiving the informations, right? So basically there are 2 phases are required for into the reactive routing protocol. First one is the route discovery and second one is the route maintenance. Okay, Route discovery means searching the different nodes for transmission and for reception. Second, if the link is damaged between the two nodes, it has to repair itself, right? So there are various algorithms are there for repairment of the nodes into the MANET system, which is on reactive routing, on-demand routing protocols. So in that the examples are dynamic source routing protocols. So that is a DSR, as I have given the example. So that is completely based on the dynamic source routing protocol. So this is completely depends on the reactive on-demand routing protocols. So in this type of routing, route is discovered only when required or needed. Then the process of route discovery occurs by flooding the route request packets, as I just mentioned in the previous slide, throughout the mobile networks, and it can follow two phases. First phase is the route discovery, and second phase is the route maintenance. Okay, so as I said earlier, ad hoc on demand vector routing protocols, that is the AODV. So in that, again, this is the advancement of the DSR. So it will remove the disadvantages of the DSR. So in DSR, after route discovery, the source mobile nodes send the packets to the destination mobile nodes. Okay, and it also contains the complete path in its header. Okay, so in that case, the network size will be, for the large network size, the header size will be increased. So length of the complete path is also increased, and in this case the overhead will be increased. So to avoid this situation, because if we require the overhead is large, in that case the bandwidth will be large, right? So efficient utilization of the bandwidth will not be there. So that is why the solution for that one is the ad hoc on demand vector routing protocol, in which what happened here, in the AODV, which stores a path in the routing table, whereas DSR stores in the data packets. This is a very big difference, right? So in the routing table is there, then the extra or raw information will be updated regularly. But in DSR, what happens, when the data is transmitted, along with the data, the header will be added into that. These are case of the DSR, right? But in AODV, ad hoc on demand, what happens, the tables will be updated separately, and after that another packets will be transmitted, which is used for the data transmission. Next is the hybrid routing protocol. As I said, it basically combines the advantages of both the reactive and the proactive routing protocols. So these are adaptive in nature. So as adaptive in nature and adapts according to the zone, okay, and position of the source and destination mobile nodes. So one of the most popular example of the hybrid routing protocol is nothing but the zone routing protocol. So what happened into that? In zone routing protocol, they divide the complete network into the different zones, and different zones will have the different number of users or the number of nodes into it, and it can be changed. It can be due to the mobility of the nodes, so number of users or the nodes can be changed. It can be increased, it can be decreased into the given network. Okay, so again, I have just mentioned the previous slide as well. As I said, in the hybrid, if this is the zone 1, this is the zone 2, right? If, as I said, if the source and destination is into this particular zone 1, so in that case, this will be the this is the proactive routing protocol can be used. If we have the zone 2, source is here and destination is here in zone 2, in that case, what will happen? The reactive routing protocol can be used into this. So I hope this point is clear to all of you. These are very interesting, very important topic in wireless communication system, that how to design, what is the significance of the mobile ad hoc network. So I hope you got some intuition about this MANET system. Thank you very much.